Hello. In this bonus video, I'm going to talk about the derivation of probability mass function for the Poisson distribution. I'm going to just concentrate on the arithmetical part here because the probabilistic derivation, I'll talk about it in the during the lecture, main lecture, and the derivation actually, the part which I didn't do consisted of f(x) is equal to limit as n goes to infinity the number of trials and once I have written this, I have just skipped the steps in between and found the final result, which is actually equal to so here basically I'm going to be talking about this proof here. So what I'm going to do is I'm going to separate these terms into, first I'm going to write this as a product of two terms, which is minus x and n. So hence we have actually four terms here. I'm going to call this 1 and I'm going to call this 2. And this one 3, and last of all this one 4, and I'm going to try to handle each of these terms one by one. So starting with the first part. The first part, actually this part is related to a definition of exponential. Actually, I'm not going to go into the proof of this, but I think you should have seen this in some of your courses related with calculus, I guess. So this is actually the exponential is also equal to this expression. So what we are going to do is we are going to liken this expression to this form so that we are going to replace this expression by n. Actually, it's pretty much easy. What we do here is if we write this expression inside the parentheses as n over lambda t, and actually I'm going to make a plus here, therefore this is going to be minus. So therefore this whole term is going to be equal to y. And if I increase this to the power of minus and lambda t, that's great. Then if I multiply this whole thing by a raised to the power lambda t, note that these will cancel, and minus signs will cancel. I'm going to be obtaining n here. So this expression will be equal to this expression. So what is the advantage of writing this expression instead of this one? Once you write it that way, note that here this one is equal to y and this whole expression is equal to y. Therefore, this expression will be identical to this one. So you can replace this whole thing by exponential. So the result is going to be exponential minus t. All right, so this is what the first term, or how the first term can be reduced to this form. Now the second one, for the second one, I'm going to be just directly using, since this is limit n goes to infinity, I'm going to be just directly using this equation here. Note that this n, when n goes to infinity, these are finite value numbers. Lambda is a finite value, t is a finite value, x is a finite value, right? None of them has some limits like, or limit that goes to limiting values. Therefore, when you put infinity here, this is going to be 0. So the whole thing is going to be equal to 1. So let me also show it with 1 here. So 1. That's great. Now I have also the second term here. I have found the second term, 1 and 2. Let's continue with 3. This one, for this one, I'm going to be just writing, I'm going to be separately writing those two, which is great, straightforward. And for the time being, actually, I'm going to separate this term here. So it's going to be another term which comes from here, and I'm going to handle this. So it's going to be lambda t to the power x is the third term I'm obtaining here. I'm going to come to this in a minute. And the fourth term is this one here. Let's write it. This n times n minus 1, n minus 2, which goes to n minus x plus 1, and then n minus x factorial divided by n minus x factorial x factorial. Now, when I do that, I get rid of these two terms, and I have an x factorial here, and I'm going to also separate this x factorial here. So I have these terms here. So what is left is this part and also this part. Let's add 4 and 3, the remaining terms of 4 and 3. Limit n goes to infinity. Then I have n minus 1, n minus 2, which goes to n minus x minus 1. I can write it that way. And this term is going to be n to the power minus 1 is going to be n to n. Now, how many of these elements do I have here? I have here, note that x of these elements, n to the power x. And here, starting from 1 to x minus 1, when you include also this term here, I have also, note that x terms here. Now, if I divide all the terms in the numerator by n, by 1n, then the denominator is going to be equal to 1. And the numerator is going to be 1 times 1 minus 1 over n multiplied by 1 minus 2 over n. It goes like this. And it's going to be 1 minus x minus 1 over n. And let's remember that this is still limit n goes to infinity. Now, when I apply this n goes to infinity here, note that all these terms will go to 0. So therefore, it's going to be just simply equal to 1. Now, let's wrap up all the things that is left. So we had this one, exponential, let me, here, lambda t. Here 1, I don't write this. This is lambda t to the power x here. And I had an x factorial here in the denominator. And this expression, note that, is exactly equal to this expression that I would like to prove the equivalence of. So that's the end of the derivation. It's kind of a fun derivation, and the only thing that is required to know is the exponential, the relation of the exponential in terms of that infinite series, except that it is just a couple of arithmetic tricks. So that's all.